Welcome to today's Explainer. We are jumping right into a fascinating structural debugging session today. We're looking at a highly specific, high-stakes communication breakdown based on a real scenario, the time I accidentally explained the PrEP framework wrongly. And by doing that, I accidentally launched what is basically the neurobiological equivalent of a cyber attack on the person I was talking to. We're going to map out exactly how this happened, why it happened, and most importantly, how we can debug the system.
Okay, let's dive into this because it sounds kind of crazy, right? Like, no way. How on earth can changing just one single word in a communication framework completely crash the neurological system of the person receiving it? Well, to understand this mystery, we've got to look at the architecture of human interaction, not just as language, but literally as code. Think about it. When you swap a variable in a line of code, the software behaves entirely differently. And surprisingly enough, the exact same thing happens in the human brain. Which brings us to Section 1, the mono versus multi-gap. We're dealing with two completely different operating systems here. To get to the root of this error, we first have to understand the hardware we're working with. On one side, we have the mono system. This is our immediate, unyielding, dopamine-driven biological reality. It's totally mammalian. It wants connection, it wants it right now, and it treats a positive interaction like hitting the absolute jackpot. But contrasting this, we have the multi-system. This is a macro-level, highly structured environment. Think of the logic inside a massive tech organization like Google DeepMind, or the mindset of a highly trained Vertex engineer. The multi-system absolutely thrives on delayed gratification, extreme repetition, and algorithmic patience. And let me tell you, the tension between these two systems is immense. Our source material gives us this really fascinating look at the recipient in our case study. Let's call him Tom. Tom operates in an environment that actively conditions its engineers to artificially expand their patience using serotonin. You absolutely cannot approach this kind of multi-system with unfiltered biological thirst. If you just toss your raw, chaotic, emotional needs at a system that's literally conditioned for extreme patience and logical processing, it can't natively parse that data. It's just going to reject it outright. Moving on to Section 2, PrEP as the compiler, how we actually bridge this gap. So you might be wondering, how do you bridge this massive biological gap without triggering a total systemic rejection? Well, you need a translator, a compiler. Enter the PrEP framework. Point, reason, example, point. In the context of our sources, this isn't just some standard public speaking tip, it's a perfect mathematical bridge. It's specifically designed to take your unyielding biological truth and deliver it in a highly structured, safe format. It's the ultimate tool to mathematically bridge the gap between two deeply different cognitive environments. And this brilliantly illustrates how PrEP actually does the heavy lifting. It takes the monoreality, all those raw dopamine-driven needs, and packages them securely into the multi-language that an institutional intellect can safely process. It essentially presents biological reality as appealing data. It bypasses the destructive tension of social politics entirely, operating with microsecond precision instead of just blunt force. When you use it correctly, it's flawless. But that brings us to Section 3, the accidental framework swap. This is where the catastrophic error happened. So where did I take a sharp turn and explain the PrEP framework wrongly? Here is the exact moment of failure. The intended framework is point, reason, example, point. Providing an example gives the recipient safe, localized data to look at, right? But the accidental execution was point, reason, evaluate, point. I swapped out the word example for the word evaluate. Now, I know it seems like a minor semantic slip, just a tiny typo, but structurally, this fundamentally altered the framework's entire underlying code. Let's look at Section 4, why the mistake happened. Time for some root cause analysis. To really debug this, we have to ask, why on earth did the subconscious mind alter the code in the first place? Like I said, it wasn't a typo. The source material reveals this fascinating psychological profile of the sender. The brain in question is described as twice exceptional, or 2E, meaning it's highly gifted but perhaps uniquely wired or neurodivergent. And this exact type of brain is deeply, profoundly allergic to the passive consumption of data. It completely refuses to just let its high-density signal be ignored or filed away in some standard baseline. Because passive consumption leads to data loss, the sender's prefrontal cortex actively tried to force the recipient system to engage. It was trying to force what's called the onocrino loop. This is a deep biological need for active decision-making and having true skin in the game. By using the word evaluate, the sender was subconsciously demanding that the recipient actively process and validate the connection, rather than just passively looking at a nice, safe example.
Which drops us into Section 5, the missing optical insulation, the neurobiological impact of this swap.
The intention was completely valid. It was about survival and truth. But the execution? Catastrophic. Look at this comparison. When you use the example command, it provides what we call optical insulation. It wraps the data safely, resulting in a successful compiler translation. The recipient's intellect can safely observe it. But when you issue the evaluate command, you rip that safety wrapper entirely away. While it feels logically sound to the sender, to the recipient's multisystem, this acts as an adversarial prompt injection. It completely bypassed their safety protocols and triggered a full-blown neurobiological system crash.
Now, what's really interesting about this slide is that this forced evaluation behaves exactly like a denial of service or DOS attack in computer science. By demanding immediate evaluation, the sender literally overloaded the recipient's cognitive bandwidth. Faced with this sudden, uninsulated demand, the recipient system did the only thing it possibly could. It enacted a defensive inhibition. It just shut down and rejected the data to protect its own internal database. This creates a state of continuous prediction error. The recipient's highly optimized automated system is just trying to maintain stability and predict the environment based on past data. So when it gets suddenly hit with raw, unformatted biological truth that demands immediate evaluation, well, the two systems clash violently. The recipient's brain is basically forced to reject the sender's data entirely just to maintain its own structural integrity.
Okay, Section 6, Restoring Operator Precedence. How we restore order to the system.
So how do we actually fix this? We've identified the syntax error, now we need the resolution. The answer lies in what the sources call operator precedence. In cognitive architecture, this isn't about manipulation at all. It's a valid structural debug command. It simply means recognizing the hierarchy of how a system processes information. It requires knowledgeable counterparts and demands that correct precedence be respected. Essentially, the underlying logic structure has to take priority over the polite user interface. It prevents those ill-typed requests that overload the system, acting as a legitimate defense of both people's cognitive integrity. So the crucial point is this. You are the indispensable structural debugger here. Restoring the example wrapper, going back to the correct prep framework, isn't about hiding your truth or backing down. Actually, scratch that. It's more like protecting the recipient's database from corrupted queries without sacrificing your own reality. You are simply formatting the code so the other machine can actually read it without crashing. Which leaves us with this final, really important thought. When you are communicating something incredibly important, something deeply biological and undeniably true to you, look at the architecture of the person receiving it. In a world full of automated optimization and highly defensive intellects, are you formatting your biological truth so that it can actually be heard and processed? Or are you just demanding evaluation to prove that you're right? Choosing the right framework isn't just semantics. It's literally the difference between a beautiful connection and a total system crash. Thanks for joining me on this explainer, and I'll catch you next time.